Okay, guys, so I'm going to be going live shortly. I am going to keep this just, I'm afraid, to the IGCSE possible questions for the IGCSE higher paper. I've had quite a few people email me some questions to do last minute. I'm just not going to have time tonight, I'm afraid. So I'm just going to be keeping the anything I do tonight just to those topics that are in front of the screen now, I'm afraid. So here are our 15 topics that I think could come up in the IGCSE paper higher tomorrow. So here are our 15 topics that I think. If you want me to go through any questions on those, I'm quite happy to do so. I know some kids at my school were thinking of perhaps logging on. If they've got any specific questions, I will do that. But I do really want to just keep this quite brief and really keep it just to those 15 topics that are listed there. So I'll stay live for a few minutes and see if anybody's wants to go through questions on those 15 topics. So any of those 15 topics, I mean, if you are doing the GCSE higher, that's not to say that some of those topics won't be coming up. So do feel free, even if you're doing the GCSE, to ask. But I just really want to keep it focused. I really want to prioritize really the kids I teach in my school. So it's just going to be the IGCSE higher topics, just carrying on from what we did after school today. So if anybody wants me to go through any of those 15 topics, let me know, and I'll stay online for another 10 minutes or so. Okay, so I think recurring decimals to fractions could well come up. Bounds, so that's lower bounds, upper bounds, all that sort of stuff. Completing the square might be a simple one with a single x squared, or it might be a 2x squared. Direct proportion, so remember, start off by k multiplied by whatever, or indirect proportion, k divided by whatever. Sequences, I think that could very likely to come up, particularly as it's the new graphs. I think that could well come up. And then solving linear simultaneous equations, or non-linear simultaneous equations. I think that could well come up. We haven't had anything on differentiation yet. We've had very little on angles or histograms. We've had averages from group data, so I don't think that's going to come up. But we could easily get averages just from a list, or the interquartile range just from a list. So that might be worth a look. And then we've got SerDes, and there's been very little on SerDes so far. And there's also been very little on fractions so far. So it's 4 minutes past 7 now. I'll give it a few more minutes, because those kids at school, I did say if they had any last minute queries, I'd come online at 7. So I'll give it until 10 minutes past. If nobody's come through with any questions by 10 minutes past, I think I'll pack it in. Okay, so that's the sort of recurring decimal type question. If anybody needs that talked through. then we could have a look at that. That's another one of the same. I think we could look at rationalizing a denominator. So could you do 14 part B? Bounds, I think, will come up. So will the bounds be one of these where it's finding the upper bound or lower bound when you divide? Or alternatively, it might be one like this question at the bottom, where you're finding the upper or lower bound when you're multiplying some terms together. That could well come up. Completing the square hasn't appeared yet. Inverse proportion, where P is inversely proportional to Q, that hasn't come up yet. Or it might be that we've got it being directly proportional. So remember, your opening line there would be P equals K multiplied by R cubed. Okay, I think we're bound to get one of these cropping up. I mean, it's the new topic to the IGCSE, so I would be very surprised if we don't get any where we have to look at arithmetic sequences. Okay, if one of those comes up, then we're going to be using, I'll just put the formula down just in case anybody needs to. Okay, then we might get a quadratic graph question. We may get a normal simultaneous equation like the one at the bottom here. So just remember, what would you do here? You've got to line up the x's and line up the y's. So you might, for example, multiply the top equation by 5, the bottom equation by 2. That will give you 10x on both occasions, 10x and a 10x. So you would have to take away one from the other in order to eliminate the x's. Okay, hi Lily. So, right, that's the list. So, yeah, so 0.9 was differentiation. So, we did run through that at school, but if you want us to run through the differentiation one again, Millie, that's fine. All right, we could look at, just remind ourselves with the angles, parallel lines or interior and exterior angles. We'll go through the histogram question again. And you never, we might get an averages and quartiles just from a list of data, so I don't mind looking at that again. So where was I turning the pages? We got to the simultaneous equations, so we've done these. Okay, so this is the ones, so we've covered that one. Now, this is a more complicated simultaneous equation question. So this is one where you would take the, you take this linear one here, make y the subject and substitute it into the other one. Right, Anna's just asking if we can go through the recurring decimal one. Yeah, that's fine, Anna, no problem. You haven't missed anything, we've only just started. Okay, so going back to number 1. Okay, use algebra to show that the recurring decimal 0.3454545 equals 19/55. So what you would do here, you start off by letting x equal your recurring decimal. So 0.3, and remember, it's 45 being repeated over and over again because it's got the dots on top of it. So 45, 45, 45, and so on. Now, what you've got to remember to do is, because we've got 2 dots, you're going to choose to multiply by 100. Now, the way to remember that is 2 dots, 2 zeros. So if you've got 2 dots, multiply by 100. If you had 1 dot, multiply by 10. So if we multiply x by 100, we get 100x. And if we multiply the decimal by 100, everything moves over 2 places. You get 34.5454545, and so on. Now, what you will see is that once we get beyond the first decimal place, our numbers are now lined up 4455, 4455, 4455. That's what we wanted, because what will happen now, if we call that equation 1 and that equation 2, if we choose to take equation 2 and take away 1, we will get rid of the recurring decimal element. So what I mean by that is this. So watch, 100x take away x is 99x. 34 take away 0 is 34. Put the decimal point in. 5 take away 3 is 2. And then everything else cancels out. 4 take away 4 is 0. 5 take away 5 is 0, and so on. So now we've got 99x equaling 34.2. And we're just going to have to rearrange this. Now, it's a bit of a nicety here. It's probably not essential, but I'm not too keen on dividing by 99 at this point. Okay, yes, Anna, just going back to your point, my tutor said you can times by 10. Is that the same? Well, no, you can't times this one by 10, Anna, because if you did, you would not have the 4s and the 5s lined up. You would still be 1 adrift. This has only worked because I have been able to move everything over 2 places. So you can only multiply by 10, Anna, if you've got a single dot up here, okay? I think that's what you're getting at. If you've got another method where you're multiplying 1 by 100 and 1 by 10, I don't know. I don't know what your tutor said to you. Okay. Yeah, you could use larger values like 1,000. Yeah, you could. Yes, you can. You can multiply 1 by 10 and 1 by 1,000. Really, you can do what you like. But bottom line, you've just got to choose to do whatever you do such that the recurring element lines up. So if you want to multiply 1 by 10 and the other by 100, by 1,000 or whatever, that's absolutely fine. But we're going to end up in the same place either way. Okay. So anyway, at this point, I like to multiply by 10. Okay. In a way, that could be what Mahit's getting at, that if you multiply the top one by 10, that by 1,000, you probably get the same net result. But if you multiply by 10 at this point, you get 990x equals 342. If we then divide by 990, we get x equaling 342 over 990. And then again, we just sort of fiddle it a bit here because we know we've got to end up getting 19 over 55. So let's just see what we've got to divide by. It's 18. So if we choose to divide both of those by 18, we get 19 over 55, which is what was required. Okay. So yes, yeah, Anna, yeah, if your tutor is getting you to multiply the first by 10 and the second by 1,000, we end up in the same place. So don't change a method that you're comfortable with, okay? But I personally think it's a lot easier if it's 1 decimal point multiplied by 10, 2 decimal points multiplied by 100, and then, okay, you have to do a little bit of tidying up at the end, but I just think it's an easier process. But if she's multiplying by 10 and then 1,000, we're ending up at the same place, because either method you do it, you're ending up with your 5s and your 4s lined up. So I'm totally relaxed how you do it, but that is an algebraic method to get the right answer. Okay, so you stick, Anna, with your times by 10 and by 1,000. I've got no problem with that. If somebody's starting from scratch, you know, my method's fine too. It's totally up to you. Okay, so that's recurring decimals. So topic 1 has been covered. Does anybody out there want anything else on that list covered? Okay, you better say no, because if nobody comes through, I'm going to pack it in and go and have some tea. But if you've got That said, I'm totally happy going through any of those other topics, but you are going to have to let me know now, otherwise I'm going to call it a day. Okay, so we've still got quite a few people. Yeah, no, I see several messages coming through. Oh, let's just get rid of that on my screen. I really want to just stick to these topics here, guys, please. So I don't want to go through A-level content. I don't want to go through a changing ratio question. Sorry, but I am happy going through question 18, which is on SerD. No, I don't know when it says 18, please. That's Peter, I don't know what you're getting at when you say 18, please. I don't know what question. There's only 15 topics there. I am happy going through, though, the bounds question, which somebody's just come through asking. So we'll go to topic number 2, which is the bounds question. Okay. Now, I've got a couple of bounds questions here, but I think really doing one of them will probably suffice for you getting the idea. Okay, so let's take a look at this question here. We've got y equaling 2a over b minus c, some information about a, b, and c, and we're being asked to work out the lower bound for the value of y. So we want y to be as small as possible. We're trying to find the minimum value for y. Now, if you're dividing two things, if you're trying to get overall the minimum value altogether, okay, you want the whole of the numerator to be as small as possible and the whole of the denominator to be as big as possible. We want to maximize the denominator. A small number on top divided by a big number on the bottom will give us the smallest possible y. So clearly we need to get the minimum value for a. Now, how do we make b minus c as big as possible when we're taking away? You're going to want b to be as big as possible, but c to be as small as possible. So a is going to be a minimum, b is going to be a maximum, c is going to be a minimum. So following that through, the lower bound for a is 41.5. And on the denominator, our maximum, our upper bound value for b is going to be 24.5. And we're taking away our minimum value for c, which will be 13.5. So you pop that into your calculator. So 2 times 41.5 divided by 24.5, take away 13.5, gives us 7.545, and so on. Now, reading the question says to two significant figures, so our final answer is just going to be 2 digits. So that's going to be 7.5. Okay, I'm going to move on quite quickly. Obviously, you can play the video back. Afterwards if you want to see that again. Now, I'm just going to quickly look at this bounds question on the next page, because it's the same idea but slightly different. So I'm just going to do part of this. Now, for this question, we've got to work out the upper bound of x multiplied by y minus z. Now, when you're multiplying two things together, you want them both to be as big as possible. So we want to maximize x and we want to maximize y, the bracket. How do we maximize the bracket? Well, we need y to be as big as possible and z to be as small as possible. So here you would take the maximum value of x, which is 3.5, and multiply that by the maximum value of y, 8.375, less the minimum value of z, which is 5.25. Okay, right, so just working down in order, Beta Kelly's asked for question 14, topic 14. So that's SerDes, okay? So a couple of things I want to cover on SerDes. All right, so SerDes. Now the first one I want to have a quick look at on SerDes was this question here. This question at the bottom here. Rationalize the denominator of this. Now, again, I'm not going to go all the way through this, but I just want to set you off. In order to rationalize the denominator here, that means get rid of the square roots in the denominator, you are going to need to choose to multiply both the numerator and the denominator by this denominator, but do remember to change the sign. So you're going to have to multiply top and bottom by 7 minus root 5. Okay, now that really sets you off on this. So 4 times 7 minus 4 times root 5, then your pair of brackets on the bottom, that times that, that times that, and you will see that the middle two terms, cancel. Okay, so yeah, oh yeah, sorry, thank you, Mahid. Stupid, yeah. With the change of sign, you're absolutely right. Sorry, that's what I meant to say. You must change the sign. So multiply top and bottom by 7 plus root 5. Okay, that's what I meant to say. Well, that's certainly, apologies. Okay, so you must multiply top and bottom by the denominator with a change of sign. So thanks, Mahid, for pointing that out. Now, the other rationalizing, the other SerDes questions come towards the end. Okay, and I think really the one I want to focus upon is just to check that you're okay with question 20. Okay, so we've got to simplify these SerDes for it to equal so many lots of root 2. So if we simplify both of all three of these terms on the left, we get root 25 root 2 plus root 64 root 2 minus root 100 root 2. All right, we're just breaking each of the bus shelters, if you like, down into two numbers that multiply to be the term. All right, and one of which being the biggest square number possible. So the square root of 25 is 5, so 5 root 2 plus 8 root 2 minus 10 root 2. Now, Molly was pointing out to me earlier on, you can just simply put these three terms into your calculator and it will just throw out at you the simplified SerDes. So by all means, just put these three into your calculator and you'll get these three here. You probably don't have that luxury if you're doing the GCSE. Mind you, the non-calculated paper's come and gone, isn't it? Anyway, so gather these up. 5 add 8 is 13. Take away 10, we get 3 lots of root 2. So that would be your final answer there. So n is 3. And for part B, again, I'm not going to do this now, but you would just choose to multiply top and bottom by root 8. Now, let's have a look. So I've got, so that's really covering the SerDes for beta. Anna's asking, can you do question 3, please, afterwards? Okay, so that's completing the square. Okay, we're going to have a quick look at this completing the square. All right, so just looking at this completing the square, x squared plus 6x minus 7. Now, the secret here, we know we're going to be having x in the bracket and it's all going to be squaring, is what term goes here. And you halve the coefficient of the x. You halve what is in front of the x. Okay, so as it's plus 6, we're going to put plus 3 here. Had this been minus 8, we would put minus 4, and so on. So that is our starting point. Now I'm purely focusing on the x squared plus 6x. Now, if you multiply out x plus 3 times x plus 3, I'll just do it on the side to show you, you get x squared plus 3x plus 9. Gathering the middle terms, you get x squared plus 6x plus 9. Now, we want the x squared, we want the 6x, we do not want the plus 9. So to remove the plus 9, we need to take away 9. Now, that therefore now means x squared plus 6x totally lines up with x plus 3 all squared minus 9. We mustn't, though, of course, forget the -7. So this is the equivalent of this. And then just tidying up these two terms here, we get x plus 3 all squared minus 16. And that is now in the format that was required, with our a being 3 and our b being minus 16. Okay, so going through, Ferdowsa's asking if we could do question 1. Well, we've done that already, Ferdosa, so if you don't mind, you can just play this video back when it's finished. It was the first question we've looked at, so I'm going to give that one a miss. Then Mohid's kindly pointing out the mistake I made. Thanks for that. Then Anna's asking, can you do question 13, please? Oh, right. Anna, you probably meant, oh, yeah, ignore what I said about question 13. I think you probably meant this one here, did you? You probably did. I think you probably meant question 13, which was the topic 3 one. I'll just wait for you to confirm that. But I think, yeah, ignore what I said about question 13. Yeah, that's what you meant. So we've covered the one you wanted to do. Okay, right. Right. So somebody's asking about bearings. All right. I know it's slightly breaking the rules on what I wanted to do today, is it's not one of these topics, but given it's quite quick, I don't mind doing a really quick summary of how bearings works. Okay, so bearings, always measure from north, always measure clockwise, and always give your answer as 3 digits. So if you worked it out to be 17 degrees, make sure you give your final answer as 0.17. Okay, and that's pretty much it, really. Yeah, and it might come up tomorrow. Yes, it could well come up tomorrow. I'm not saying it won't, but it's in the scheme of things, it's quite a small little topic. So it could well come up tomorrow. This obviously isn't an exhaustive list of everything that might come up, so it may come up. I was just trying to keep things to these sort of more major topics, I think. But that's bottom line is how bearings works. So so really just use all your angle facts. So all your Z rules for angles, your alternate angles are equal, corresponding angles are equal, all your normal angle facts. But then just really to take the bearing bit into account, just remember the 3 things I said: measure it from north, measure it clockwise, and give your answer as 3 digits, and that's pretty much it. Okay, so we're coming up to 7:30. That was really when I was thinking I would probably give it a right. Okay, oh, Nell, you've just got in time. Can you do question 20 from the January at 18 4H? Yeah, probably can, Nell. I think I've got that to hand. 4H January 18, question 20. So, yeah, okay. Let's just check I've got the right paper. I'll just pop it down here now and just check that was the one you had in mind. I think it probably is, but if you could just say yes, it would just save me going through a question that you're not wanting to. Yeah, cool. Now, first thing I'd say now, I think the likelihood of part A coming up is slim because it came up on the last paper, and nonetheless, we'll do it anyway. So just going through this one. So the way to do this now, first things first, deal with the minus sign, then deal with the cube rooting, which is the 3, and then deal with the squaring, which is the 2. So 3 things. So first things first, dealing with the minus, that just flips everything over. So at that point, we're going to get 27f cubed over 125 e to the 12, and now we are just to the power of 2/3. So all we've done so far now is just lose the minus bit from the power by flipping over the 2 terms in the bracket. Now, step 2, I'm going to cube root. Now, the cube root of 27 is 3. The cube root of 125 is 5. So that's just normal cube rooting of normal numbers. Now, with regard to the cube root of f cubed, that's just f, or f to the 1 if you like, but just f. All right. Cube rooting f cubed is just f. And then the cube root of e12, well, you just divide the 12 by 3, so that would be e to the power of 4. So that sorts out the cube rooting, and then finally now we just need to square everything. So 3 3s are 9, f squared is f squared, 5 5s are 25, e to the 4 squared is e to the 8, and that would be your final answer for part A. Oh, and part B, now this is difficult, okay? Given that this is this, express x in terms of n. Okay, right. Let's look on the left-hand side first of all, okay? Now on the left-hand side, when we're multiplying, we add the powers. So we can say that we've got 2 to the half plus n over 3. Okay, that's just normal index law. When you multiply, you add the powers. Now on the right hand side, we've got to be a bit clever here. We need to turn both of these terms into powers of 2. So the 8 is 2 cubed to the power of x, and the 4 is 2 squared to the power of n. Now just multiplying these across, that is 2 to the 3x over 2 to the 2n. And then by the index law for division, when you're dividing, you take away the powers. So that would give you 2 to the 3x minus 2n. Now, look what we've got now. We've got 2 to the power of something equals 2 to the power of something. So these two powers are equal to each other. So we can now just forget the 2. We can just say half plus n over 3 equals 3x minus 2n. Now, so now we've just got to really express x in terms of n. So we just need to make x the subject of this, okay? Express x in terms of n. Express x in terms, that's right, okay? So I think I'm just going to, I think I've got this right. It's getting a bit complicated. I think this is right. So, so at this point, we've got, I'm going to choose to, what are we going to do here? We're going to, I want to tidy this up. I just think this is messy. I'm going to times everything by 6 to just get rid of this dividing by 2 and the dividing by 3. So we're going to get 3 plus 2n equals 18x minus 12n. Now, if we then go and add 12n to both sides, we get 3 plus 14n equals 18x. And then dividing by 18, we get x equals 3 plus 14n all over 18. And I think that's right. I don't have the answers readily to hand, but it's certainly something like that. Okay, I might have made a little slip. I don't think I have, but that's the principle. So I hope that helps now. Right, last one, I think. Lena's just asking, or Lena, sorry if I said your name wrong, is asking for the quadratic graph. So let's just have a quick look at the quadratic graph one. Okay, the quadratic graph was the question 6. Topic 6, rather. Now, quadratic graphs. Remember with these, we just love talking about this being a smiley face. Okay, these are always positive parabolas. So you just need to basically substitute in these x values in order to work out the y values. But I'll show you a little tip in a minute. Start off with a nice easy one. Why not start off when x is 1? So when x is 1, we're going to say y equals 1 squared, which is 1, minus 4 lots of 1, which is minusing 4, then adding 2. 1 minus 4 add 2 is minus 1. Now, I shouldn't really have put that there. That's going to get in the way. Now, what I want you to look out for is the symmetry. Okay, so that minus 1 ripples around to that minus 1. So just imagine dropping a pebble into the stream there. That minus 1 ripples out to that minus 1. That 2 ripples out to that 2 there. And whatever I'm going to get over here is going to ripple out and be the value over here. So I'm going to do the positive 5 one and then just repeat it over here. So when x is 5, we get y being 5 squared, which is 25, minus 4 5s are 20, add the 2, so that is 7. So that is 7, that is 7. Can you just give me 2 minutes and I'll come with you? Okay, so that's going to be minus 1, 7, 0, 2, 1 minus 1, 2 minus 2, 3 minus 1, 4, 2, and 5, 7, and you're drawing that graph. Now I want to go now because I just want to see my daughter off to uni. All right. If any of you want me to come back on, I'm quite happy coming back on in a bit. Just let me know. Okay. Cheers, guys. Good luck tomorrow.